Okay, well, since I'm recording, let me go ahead and just kind of recap very quickly what's going to be happening next week. Remember, Tuesday and Thursday are the late start days. The tardy bell will ring at 1:35, so 1:30 is when it'll ring, letting you know to go to class. Tuesday afternoon will be 1 through 4th, so I will see you. Thursday afternoon will be 5 through 8. I will not see you next Thursday. On Tuesday, we have about 30 minutes. You'll have a binomial theorem exit ticket. The homework you picked up today will be due on Wednesday. Won't see you Thursday. Friday will be a quiz over series, the homework that we just turned in today. In fact, your next exam is scheduled for the 18th. So I want to say that's a week from Thursday. Okay. Well, to finish up the binomial theorem notes very quickly, I mentioned several days ago that while I was going to show you one problem like it, for all the others, I was going to go ahead and tell you what combination I wanted. So here, I'm not asking for the third term, like the fourth term. I'm going to go ahead and say what combination specifically I do want you to find. So I want the a squared b squared term for x minus 3 to the fourth. Okay, so does anybody remember how we did this the other day? How do we set this up? What do we know so far? Was there some kind of notation maybe that I used? Combination, okay. So we have a combination of n and r. So do we know n? It is 4. Remember, n is the power you're raising the binomial to. So that would be 4. Do we know r? Remember, there was some kind of pattern we noticed the other day about that r. It always matched up something. There you go. Okay, so Aiden's right. Whatever power the b term has, that's going to be your value of r. So I'm looking for a combination of 4 and 2. Now, in this case here, we've always referred to the terms as a and b. So here a is equal to x, and b is equal to negative 3. Remember, we want to keep that term negative if it's being subtracted. Well, we're looking for the a squared b squared term. So the term that represents a, I'm going to go ahead and square it. I'm just going to replace it. So I want b squared, so I'm going to go ahead and say negative 3 squared. And now we just need to go ahead and simplify and end up with whatever term we do. But how do we solve a combination? What was that formula again? And let's say in terms of n and r. N factorial. There we go. Okay, so here we're going to go ahead and plug in everything we have. So 4 factorial over 4 minus 2, 2 factorial times 2 factorial. Okay, according to the values that I have. Okay. Now remember, a factorial tells me that I'm going to multiply a value by the decreasing values that came before it, like 4 times 3 times 2 times 1. But we can go ahead and stop and simplify. And here it really doesn't make too much of a difference. The 2's are going to cancel, but ultimately that'll leave me 12 divided by 2, which will give me 6. So the combination of 4 and 2 should give me 6. Times x squared is just x squared. Times, what's a negative 3 squared? 9. Okay. So now all I need to do is just take a product of that. So 6 times x squared times 9. What am I looking at? 54x squared. There we go. That would represent the a squared b squared term. Okay. Good, 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 good. All right. Now we have number 10, where we're going to do the same thing. But this time I want a squared b cubed. A squared b cubed. Okay. For 3x minus 2 to the 5th. Would anybody like to come on up and show me how to do it? Who's somebody who's never been up to the board? I actually think, Jack, you've been up to the board, right? Yeah. Okay. Skylar, I know you've been up to the board. Well, I don't know if I would say continuously, but okay. Been up to the board. I know there's only a few people doing the nose thing. Everybody else. Let's see. Stephanie, have you ever been up to the board before? You have? Think so? You're positive. Okay. Shayna, what about you? You have? Stevia? A whole lesson where you talked in the headphones? Okay. Okay. Who is not? Rhett, have you been up? You have? Okay. Bethany? Oh, wait. No, you shook your head no at first. No, you went, no, no. Why not? Come on. What's the worst that can happen? Well, look, it's a Friday. You know, we want to end on a strong note. But that's okay. I mean, no, we're going to help each other out. I'm going to help you. They're going to help. There we go. All right. We got a volunteer. Okay. I don't think I have, even though, you know, I've never really been here. You know. Okay, so we need to start with the combination. So let's go ahead and put C. Now, what's the value of N? 5, okay. What would the value of R be? Not 0. Now, if I were to expand it, we always start with R equals 0. That's true. But remember, R is going to be the same as the power on the B term. 3. There you go. Okay. So now, I want to accompany that with A squared B cubed. But what is the A term here? 3x. So I want to take that 3x and do what to it? What's it want me to do to A? Square it. So right next to your combination, let's go ahead and put parentheses 3x, and then let's square it. Okay. And then what do I want to do to B? Okay, but what is B? -2. That's it. So right next to 3x squared, we'll put -2 cubed. Perfect. Now we just have to simplify it. So let's go ahead and fill out the formula. Maybe we can do that on the right side. So the combination of 5 and 3, what would go in the numerator? 5. 5 what? Yeah, let's do it over there. So 5 factorial over 2. And then 3. There you go. And now let's simplify that. So where can I stop decreasing with 5? Okay. So 5 times 4 divided by 2. 10. All right. So now let's come on over here, below the combination, let's go ahead and put 10 times. Now what do I get if I square that product 3x? 9x squared times. Now what do I get if I cube -2? There's just one detail. What kind of 8 would that be? Negative. There we go. So now all I need to do is multiply that together. 10 times 9x squared times -8. Hey. Okay. Thank you, Alyssa. Okay, so -720 x squared. Perfect. That's it. Good job. See, there you go. All right. And who knows, maybe that brief minute up at the board just inspired Bethany to travel down a path of education and become a teacher. Zach? Zach? I like how I'm calling Zach's name. He's all, peace. All right. So any questions? Okay. Well, let me go ahead and show you again. I did this quickly at the beginning of class for those folks who were leaving to the concert. If you look at numbers 13 and 14, okay, I did make a mistake on the powers. Number 13 should be a cubed b to the fourth. And number 14 should be a to the fourth b squared. Okay. Instead of the fifth and second term. And then, of course, these are 15, 16, 17, 18 down here. Okay. Then start over again at 9. Okay, so you guys still have a good 22 minutes. I would say you could probably, if not get the entire thing done, get the majority of it done, because I don't think it's too challenging. Does anybody have any questions about what's going to be happening or about the lesson? Okay, then I'm going to turn you guys loose. Let you do your thing. Oh, I do need to go ahead and show you one thing very quickly. What are we starting on Monday? Conics, right? So we're going to start with parabolas. Now, one of the things we're going to have to do is complete the square. Do you guys remember that from Algebra 2? Does it sound familiar? Okay, well, just in case, what I did, if I come on over here, let me go to Classroom. Okay. So I did this the other day. In the newest listing for next week, the week of the 8th to the 12th, I did go ahead and upload just some more notes on completing the square with the answers to help you out. Now, the notes aren't filled in, but I did go ahead and record myself going through it. Hi, folks. Thanks for taking. Okay. Well, just in case you don't remember completing the square, you have that available. You can go ahead and take a look at it, ask me questions, because we won't really have time to stop and discuss completing the square with what we're doing. Okay, so that is available. That is available. All right. Other than that, here we go.